Hello everybody. In today's lecture we will see how can we perform operations in a binary writing mode. Yesterday's lecture was focused on the text writing mode. Now how do you define a binary writing mode and a text writing mode? So text writing mode is like just plain text like your notepad files, C files, Python files, anything that you can open in notepad and that makes sense, right? For example, I am having the C file. I am opening with notepad C. This is the text content which is displayed, right? Similarly, now let's say we have an application file, right? Now application file is a binary file. Why? Because when I open in notepad, you can see this is a gibberish text. Similarly, if you open any PDF editors or something like that, let's say this is a zip file. If I open a zip file in notepad, so again you can see, so this is not a text file, right? You see null, ext, ff. These are basically binary files. Why binary? Because internally they are coded as zeros and ones. Okay, so today we will see why we use binary format and how do you define to read and write a binary file. It's again very simple, just the same program. So for example, if you have to write a structure object into a file, right? So a structure is an abstract data type, right? So in structures you can see, let us for example, I have a structure record having three integers. So what is the size of this structure? The size of this structure is 12 bytes because one integer takes 4 bytes. 4 plus 4 plus 4 is 12. In the main, I am defining a file pointer that we saw in the previous tutorial, and then structure record my record. So I am making an object of type struct record. Now you see I am opening a file in write mode and you see the letter B here. So B stands for binary, right? Yesterday we just saw an example to write W, right? So without the B it is a text mode and with B it's a binary mode. So this defines that we are writing a file test.bin and in the binary mode. So like this, for example, if not file ptr, or you can also write if ptr underscore my file is equal to null, then we are unable to open the file, right? Since it's a write mode, if this file does not exist, it will create the file. If this file exists, it will blank the file first and start writing. Now I'm just printing the size of the structure. The size of structure is 12 bytes as we saw. Now I'm writing a for loop for counter equal to 1, counter less than equal to 10, right? So it will execute exactly 10 times and counter plus plus. So what I'm doing, if you see my structure has integer x, y and z, my record is an object. So my record.x equal to counter. So the first value of the counter will be 1. Okay. Simple for loop. Now what happens next? I am doing an fwrite. So when you write a file in binary mode, you have to specify 4 parameters. See, first this is a pointer. So this pointer is an address to the structure object, right? Because you see my record here is for the structure record my record, and ampersand my record gives me the address for this particular object. Then size of structure. Remember, because structure is 12 bytes, given a block that you write, you have to write 12 bytes of the structure. This is the block size. So at a time we are writing one block. And ptr my file. This is nothing but like we saw fp yesterday, right? This is a file pointer. So what is the file pointer holding? File pointer is holding test.bin in binary mode. And what I am writing? I am writing the entire record. So what I am writing? I am writing the value of x, the value of y, and the value of z. In this case, I am only initializing the value of x, so y and z will automatically be 0, right? And finally, I close the file. So if you see from my previous tutorial yesterday, which I have T1, T2, T3, the only modes that are changing here is we just make this as binary mode, and instead of simple fwrite and the object name, we have to specify 4 parameters. The record that you wish to write, basically a pointer to that record, the size of the object that you are writing, the buffer size or the block size, and the file pointer. Okay, so just observe here, besides the main there will be a file created, but it will be a binary file, so you won't make any sense out of it. Let me run the code. See, size of the structure is 12 bytes because we have three integers, and now you see this is the output which is generated. Of course, it makes no sense to you, and that's all absolutely fine because it's a binary mode. As I give you the example of the zip file opening in Notepad. When you open a zip file in Notepad, it will show you some gibberish text similar to this. Now again, I will show you. Let me erase this program. How to read through this. So reading again is very simple, just like the previous day. So we have the same structure XYZ. I have the same file pointer, this one. And now see, instead of write B, I am making it RB. R stands for read and B stands for the binary object. Okay, so if not file PTR, basically if this is null, basically you want to say the file does not exist. And remember in the previous case we had 10 bytes, we had 10 counter value. So we are keeping the same counter value. Let us just display the value of X here. Same thing, like for fwrite, if you see, let me just copy it. So if you see the record, same syntax is used. Let's see this. For writing, I used my record, the address of the structure object, then size of structure record, again size of structure record, then number of blocks, which is one block, that is by default, and the same object. So fread and fwrite, both the syntax is same. Give an address to the object, provide a pointer to the object, size of the structure or size of the array that you are specifying, block size, and then the file pointer. What I'm saying, I'm just printing whatever I'm reading. So my record will hold the values of X, Y, and Z. Out of that, I'm displaying the value of X from the file, and finally I'm just putting a blank line just to show. So I have this test bed, does not make any sense, but since I'm reading in binary mode, the compiler will understand. Say this 1 2 3 4 5 6 7 8 9 10, right? Remember, I'm printing my record.x. So initially when we wrote to the file, we wrote it in the binary mode, saved as binary mode. So binary mode has a lot of advantages. First of all, it compacts the file size. It takes lesser space because in text mode, every character is taken as a byte, right? So if you have 10 characters, it will take 10 bytes. In binary mode, the format is compressed. Okay, and binary mode is useful. For example, if you want to make a copy of a JPEG file into another JPEG file, so you cannot use the text mode, right? So you have to use the binary mode, open that file in binary mode, and then copy it block by block into another file, right? So mostly when you deal with structures, this method will be very useful. So for example, if you are given a structure program that you need to save to a file, you have no other option but to save it as a binary object. Okay, so yesterday we saw append, write, and read. Okay, so today we will see another example of how you can manipulate the distances of the cursor in a file. So how do you define a cursor? So this blinking object on line number 3 is the cursor, right? So I have commented few things, but I will explain you showing an example. So let us take a file pointer fp. Now what I am doing, I am opening the file as file.txt. Let us keep the name as readme.txt, and I'm opening in W plus mode. Why W plus? Because you want to write as well as read. Now since there is no B here, no binary, so I'm reading it as a text mode. So what I'm doing, I'm taking the file pointer and putting this content into the file. Okay, so at this moment, just let us do this only and close the file. So what will happen? It will create a readme.txt and put this content. Let us put a full stop also. Right, so you see readme.txt and India is my country. Great. Now let us do one thing. So do you remember yesterday we saw the operator called rewind in one of the examples? So rewind takes you to the start of the position. Now when you write the file, the cursor is at this position. As you can see, it is at the last position. If I do rewind here, rewind FP, I will come to this particular position. So there is a function called fseek. F stands for file. Seek means as the English word seek, right? You are trying to find something. So you give the file pointer and there are three keywords: seek set, seek cursor, and seek end. Okay. So let's say I want to insert C programming language at the end. So fseek has three parameters. First is the file parameter fp, which is the file we are manipulating. Second is the offset. Offset you will understand when I explain you the cursor position. Right now just assume it is 0. And seek end. Seek end means wherever the file pointer is, seek the end of the file. So what will happen? This text, this f puts in the next line will be appended to the file along with India is my country. So when the program execute, I open the readme.txt, then I read this and basically I write this into the file, right? Then I say seek to the end. So my cursor will come here and then it will write this particular object, this particular text, I mean C programming language. So let us execute it and you will understand. Right, let us see the readme.txt. As you can see, since I had done a seek end, I am writing, I am getting the C programming language at the end of this. Okay, now let us do one thing, keep it 0 only and seek set. So set will take us to the beginning of this. So when you write at the beginning, let us see on execution. So if you see, C programming language actually overwritten that thing. So you may have feel it's not overwriting because if I had this text as longer, let me keep this as a long text. Since I said go to seek set, right? So I make my pointer to the beginning of the file. So what happens in this case? Space, see you can see there is a space here. So space will overwrite I, N will be overwritten by C, space programming language, and this text will continue. Let us just check the output. See, C programming language, and this is India is my country. Right, so this is how you manipulate. Okay, so now let us do one more thing. Let us again reduce this example to a small one. India is my country. Okay, so now let us do one thing. So we will seek some position in the file. Let us see, I say position number 3, right? If you want to go at the start, keep this as offset. Offset means, see, seek start will go to the start of the file, right? And from the start, the third position. So let us just check the output. Remember there is a space here. So let me remove the space and then we will see. Remember this 3. What I'm writing this into the file, then I say, okay, go to the start and from there seek offset 3. So jump 3 bytes, right? And then write this particular stuff. Let us do one more thing. Let us just copy this so that the program is more understandable. Let us come to readme. Okay, and let me copy this so that you can understand. So this was our original sentence. So what did we do? Then we said, okay, seek set, basically go to the start and position number 3. So I went to the start and position number 3. So 0, 1, 2, sorry. This is the 0th index, first index, second index, and this is the third index. So from this position, it tried to print C programming language. Right? I hope you get the idea about it. You can even do seek end and then do a -3. So it will go in the reverse direction. Okay. So fseek, you have the seek set and the seek end. Seek set is for the start, seek end is towards the end of the file. Right? And since we specified an offset of 5, so let us do one thing. Specify an offset of 5. Let us run the program. So what happens here? 0, 1, 2, 3, 4, and 5. This is the fifth position, the space one. And you can see C programming language comes from that particular position. So if you see, it's very easy. It's not very difficult to gauge how the seek works. So these were the two things that I needed to cover: how to read and write in binary mode. Only there is change in one syntax, f read and f write. Whenever you are operating on structures or pointer objects, please use the binary mode. Second thing, how to manipulate the file positions in, right? So basically manipulating the cursor positions. You have seek start, seek end, right? So when I have specified in my previous program seek start and 0, seek set basically gives me the start position, and 0 again give me the the exact start position. It requires three parameters. So see, India is my country is gone, and it overrides with C programming language, and beyond that the text remains the same. So that's it. Thank you for watching. Have a good day.